Hey everyone, I'm Ricardo, and it's okay. There are many different pronunciations for this word. There's like idempotency, a lot of different pronunciations. Uh, Before we start, just a quick question. Were by any chance any of you here on last year's DjangoCon? Because there was a talk by Jake Howard, if I'm not wrong, talking about Celery and background workers, and it was a terrific talk, very good. I truly recommend you watch. If you didn't, it's available on YouTube. And I'm mentioning this because I believe that this talk is like a spiritual follow-up from this, because we will be talking about Celery, but could be any kind of messaging queue system actually, and how to make it resilient enough, but still managing complexity so it doesn't explode in our faces. But okay, before we start, as we said, I'm Ricardo. I'm born and raised in Recife, Brazil. It's the northeast part of Brazil. I spent some time in Porto, here in Europe, in Portugal. I'm a software engineer at Vinta Software, which is a company focused on projects and software projects, basically fully focused on Python and everything Django related. And I'm constantly talking about architecture, both real world and software architecture. Maybe because my fiance, she's an architect, like a real world architect that builds things. So I just like to talk about it. And this whole talk is just an excuse for me to talk about architecture for like 30 minutes. But okay, what is this? What is this talk, actually? This talk is a thought experiment. It's based on a real-world case scenario that happened to me and my team. So we'll be following some strategies that we use and explaining how we do this. But most importantly, it is just a thought experiment for better understanding parallelization and software architecture, and also how we can refactor things in an organic way. So we start with a piece of code that is just bad. I think it's just like a method that breaks every so often and isn't very resilient, and we'll iterate through it and making it a bit better, just bit by bit, until in the end of the talk, we'll have something somewhat okay, but with still room for improvement. And welcome to DjangoVids. DjangoVids is a video platform aimed for the Django community, where everyone can upload their tutorials, maybe their videos. It's a new platform with hundreds of users, new ones coming every day, and thousands of videos. It is a very strong community, and new uploads are frequent in the platform. They're occurring every minute. And for each video, we run an enhancing pipeline, where the video will be like, every frame of the video will have better sharpness, better contrast, better brightness, something like that. And the DjangoVids team is saying that scaling is hard. The pipeline, this video enhancement pipeline, is getting out of hand. It's taking too much time to actually do the things. And scaling is hard, and that's normal, right? I mean, we all have problems with scaling. We have a lot of different talks about how we can better manage, database, how we can better manage our software, which tools we can do to scale better. But is it really hard? Here is a Google Trends picture. And by no means this is like a scientific research or something like this. But this picture shows that searches for architecture, software architecture, are decreasing in Google since 2004. Maybe because we already have like resources to handle those scenarios and those kinds of problems. Also have several books and articles published in this topic. Thousands of large-scale distributed systems are operating worldwide. I mean, Amazon, Netflix, Facebook, Uber, they all handle this constantly in every single second. They have a lot of different pipelines. Everything's running smoothly for them. Why not for DjangoVid? That's what we'll be looking at right now. Let's take a look at the video upload pipeline. And when I say pipeline, I apologize in advance for any data scientist or data engineer. I'm just simply talking about a pipeline is a multi-step process. So as we can see, once we upload the video, the raw video data goes through the first step, which is pre-processing, where we get the metadata. We decode something, I don't know, something like that. Then it goes through the video enhancement process, which is the most important and is the bottleneck of this whole operation. Then it goes through a thumbnail generation step, and then a speech-to-text caption creation. And it outputs enhanced video that will be available on the platform. And as I said, this video enhancement is the bottleneck right now. And why is this? This bomb code is a lot of code, but it's a simple code. And this is the thing that I said, it's just somewhat bad code. So for each frame in the video, we're making an API request. We're checking for the status code. If the status code isn't okay, we just explode everything, raising an exception. But if it is okay, we enhance the frame, save the frame, and go to the next one. I mean, there are a lot of problems here. Just a lot of problems, but do not go through them right now. We just take a bit, just a step to make it a bit better. But before this visualization may help to understand, so we start the enhancement, we iterate through each frame of the video. And for example, if we have a 1 hour long video with 30 FPS, frames per second, it's more than 100,000 frames that we'll be iterating through for just one video. We'll make one API call for each frame. We check this API response. We actually don't handle the failure, we just explode everything. And then we save the frame if it's okay. And this exception handling is a volcano about to erupt. So this is the first pain point that we can see in this whole process. We do not have any type of error handling. We have a fully synchronous API, so we go through each frame one by one, taking a lot of processing time, because remember, we do have to make an API request for each frame. So let's make it better just a bit, and as I said, this is going to be like an organic refactor, more like a small step to a better outcome. And the only change that we'll be making is putting a try except block. This isn't like some magic or some extra fancy thing, but it does handles one of our pain points. So now we can ensure that at least we'll try to enhance every frame. Before, if frame number 2 failed for some reason, the whole thing would explode and we wouldn't go through frame number 3, 4, and so on. Now, at least we try to go through them. But it does still have a lot of pain points. How can we retry those failed enhancements? How can we parallelize those enhancements and make them, I don't know, maybe faster? And here is another visualization of this. So we start the enhancement, iterate through the frames, attempt now to do the enhancement of the frame. We actually handle the enhancement error now, and then continue to the next frame. As I said, it isn't a lot of refactoring right now, but it is just a bit better. And this is the whole idea of what we're doing here, is to keep evolving bit by bit, PR after PR, to make just a little bit better. So how can we keep improving this? We can handle API and availability. We can retry failed enhancements, retry some frame that for, I don't know, maybe the API was not available for like 2 hours, and we had a lot of frames failing to enhance. How can we retry those? How can we parallelize those enhancements? And for this specific pain point, we can use Celery. So Celery, and it could be like RQ, it could be actually any messaging system, will help us make it async, which is another small step for our maybe more resilient implementation. Celery, for those who don't know, it's a very popular package in the Python community and in the Django community as well. It's a distributed task queue. It's highly available. It's horizontally scalable, which will be very important for us. And it is a reliable distributed system to process vast amounts of messages, just like our use case. Because as I said, if you have an 1 hour long video, we'll be handling more than 1,000 messages for this video alone. So this is the next step we can do to improve the enhancing algorithm. Now, instead of actually going through each frame and trying to enhance the task, now we just, enhancing the frame, now we just call a task and queue a lot of different tasks, one for each frame, to try to enhance it. Celery already has some unavailability and auto-retries configurations. As per my experience and what we had on my team, it isn't so intuitive to know to do things on Celery, those kinds of things in Celery. So it is still a bit complex. And also, how can we pinpoint why the frames failed? How can we improve this and have better observability without the need of an extra tool, for example, without the need of Datadog, New Relic, or something like this? How can we, with a Django query, just get this from our database? This is a balance between the benefits and challenges from Celery. So it's very good that now we have a async process and we can have the auto-retry capability, but we don't have a lot of visibility. It's a bit complex to manage workflows in Celery, and also the error handling isn't great. That's where the managers and idempotent executions or idempotent executions enters the room. Now we'll unlock the true power using Django's ORM. So it'll be as simple as a module. It'll be as simple as doing just a query on a terminal to get the data from this module. And why idempotent executions? Basically, from this excerpt from Wikipedia, an idempotent execution is anything that can be applied multiple times without changing the result beyond the initial application. So imagine we have a frame that we want to enhance. If we enhance this frame once, we have like better sharpness, better noise reduction, and etc. If we enhance this frame again, we may have even better sharpness, even better noise reduction. I don't know if you have any familiarity with this kind of API, with enhancement, photo enhancement APIs, but basically they always find something to make a bit better. And so it isn't natively idempotent. If we keep making the API requests, if we keep reaching out to the API, it will keep enhancing and enhancing and enhancing, and sometimes it's not even, you can even perceive a difference, but there is a difference. So how can we ensure that we'll not be trying to enhance frames that were already enhanced, skipping unnecessary API requests that will save us time and also money when we don't reach out to this expensive API? Here we entered the executions realm. Basically, you have a frame enhancement execution, which is just a Django model. It's just a Django model that has a manager. We'll talk about it later on. It has a frame, the frame from the video you want to enhance, and has a status. This status will be very important for us to have granularity over the status of each frame. So we'll know which frame failed, which frame is running, so it's being under the process of enhancement, which frames were not enhanced, and so on. So it'll be very important once you have like a parallelized tasks running in parallel with a lot of distributed workers, and it will be very easy to pinpoint which frame are failing, which frame are pending to be enhanced. Taking a look now at the manager, the video enhancement manager will have a list of frames, which we saw in the last slide. It is as simple as a Django model can be. It's just a model that has a foreign key to video, so we can keep the status, track the status of the video enhancement, and also has a status, so we will know if the manager has started, if the manager is running, how many frames of the video are being enhanced right now, and etc. And here is our updated algorithm. So basically, we create the manager, we create all the executions for this manager based on the video frames, and we once again delay the task. So that's not much different from what we are doing right now. But now, with this kind of implementation, we can have, for example, a sidecar in the background running just for the failed frames. We can keep retrying those frames every 5 seconds, every 10 seconds, every minute. We have a lot of room for improvement here that we didn't have previously. So if we take a step back and take a look at what we've done here, We came from a simple method that was fully synchronous. It broke every so often and wasn't reliable. Now, we still have a method that it can break. It may not be fully resilient and fully reliable, but now we can understand which frames were broken, which frames we couldn't enhance for, I don't know, some reason, maybe API unavailability or something like this. We can retry those frames without the need of running the for loop again for the whole video, trying to enhance again frames that were already enhanced. So when we think that each enhancement here is a API call that we do, every frame that we skip on our for loop is one less API call that we're doing. And zooming in right now on the task itself, we basically just select the execution, get the frame from the execution. We still, now we have just a status check. And this is where the idempotency enters. As I said before, enhancing a frame isn't natively idempotent. We'll always try to enhance, even if it has been already enhanced. So it's just a status check. Again, it's not something fancy. It's not like a finite state machine or something like this. It's just a status check. If the enhancement was already completed, we just skip this frame. There's no point of enhancing it again. So we do this check, try to enhance the frame. If the video enhancement throws any type of exception, we get this exception, we save the execution as failed, and we move on. We just go through to the next frame that is running in parallel. So now we have a lot of workers in parallel. We can have failed frames as we will, because we don't need to like retry every frame, just the failed ones. We can have a sidecar. We can have another design pattern to just get those frames from a simple database query. You can just query the frames that failed for some reason and retry those frames. So it's, again, it's just a bit better than it was before, and there's always room for improvement. There's always something better that we can do. Also here in the top where we get the execution, the frame enhancement execution, we do a select for update because we are now working in parallel. And sometimes when you have a lot of different workers, you may have a worker that is picking up a frame A and another worker is picking up the same frame. So this will create a race condition. We don't want this. It's a concern that it's a more complex approach than before, but it's also a more resilient approach. So this is why we need this select for update line. And this is now our algorithm, our process funnel. So we create the manager. The manager has several executions, one for each frame of the video. We delay several tasks, one for each frame of the video. And we keep checking those status because we can run the enhancement process for the video once. Maybe it will fail. Then we can run the process again, and we just pick those that have failed, and will not try to enhance those frames that were already enhanced. And if everything goes as expected, we have a enhanced frame at the end. And a question is, can we keep improving? This is, as I said, this is the main mantra. The whole point of this whole talk is there's always room for improvement. There's always something we can do to be a bit better, some step we can make to go in a different direction. So we could save our metadata in the failed executions. For example, we could know why this enhancement failed. Maybe just a JSON field in the database would be enough. Postgres has a JSON field for this. MySQL has as well. So maybe this is a small step that we can do to understand why, what we can make better for the API requests, for example, what we can make better, what we can do to be better, to be more resilient. Also, we can implement it in other parts of the pipeline. As we saw in the beginning, Django Vids has a multi-step pipeline. This is only one piece of it. So how can we use this for other steps? How can we use the same strategy for other parts of the pipeline? Can we use it? In my team, we do use it. It's something that is working for us, especially when you use the chain of responsibility. where it's a principle that we have a step that starts and runs and ends, and then when this step ends, we start the next step and so on. So the whole pipeline could be just a big chain of responsibility, where in the first step, the metadata, we run a lot of different workers to collect different metadata types from the video. Then when all these workers are successful, we go to the next one, which is the video enhancement, this one that we just saw. Then we go to the next one, to the next one, to the next one, and it's actually just something really simple to implement when you get the grasp of it. And again, it's just as simple as a Django model can be. And finally, what can you get from this experiment? Better architecture design actually will cause degraded performance. We haven't changed a lot in the architecture of the API, a lot of the architecture of the code that we are dealing with. We just basically did some exception handling and made it async. But yeah, that's step by step, bit by bit, just making a bit better. We could, for example, not make an API request for each frame, because we are now having 100,000 different requests for each video. So yeah, this could be way better than all this that we did, but it could also be a big refactor that the team's not ready to do. So it's always a trade-off to understand what you can, what you cannot do right now. Properly scaling a simple pipeline as this should not be a pain. We just saw it's like one step, then another, very simple steps. It should not take 30 minutes to run. It should not take like even 15 minutes to run. And with Celery and with async workers, we can just run more workers in parallel. We can have 10, 15, 30, 100 workers running parallel, picking up frames and running, and etc. The architecture should always be evolving as more challenging scenarios appears. So we got the problem from the beginning. We keep evolving and evolving and evolving until we have something resilient, but maybe not. It may be not optimal yet. Definitely it isn't optimal yet. But we can still improve it, and we can keep improving it as more challenging scenarios appear. For example, now we have 100 workers working in parallel. How does the API handles 100 requests coming in parallel every second, every millisecond? It's a new challenge that we need to face it as a team. Async workers are our best friends when dealing with large amount of data, but they can also be our worst enemies when dealing with a large amount of data, making, for example, an external API, a third-party API, having a degraded performance. Because now, as we said, we have 1,000 workers reaching for this API every second. We are just doing like a DDoS on this third-party API. And idempotency is key when dealing with these scenarios, even when artificially created, as we did here, because, as we said, the enhancement isn't natively idempotent, but with a simple status check, we can make it somewhat idempotent and make sure that we'll not be spending CPU cycles and API requests and etc. in something that cannot be enhanced even further. And that's it. Thank you.
Thank you, Ricardo, for the talk. So my question is, when you started doing the optimization, were you trying to save each frame details or frame into each row of the table? So like if you are having 1 GB of video, and you said probably we are considering 30 frames per second. So were you having that many frames being recorded in the sequential database?
It's a great question. For this example alone, yeah, it happens like this, but this is, as the first point of the final thought said, just bad architecture. It should be just like this. It doesn't make sense to do something like this. But yeah, it's something that we could improve, for sure. Maybe it's just a refactor that is way too big to do for the small team, for example, and doing small steps to improve the pipeline could be a better approach, maybe. But yeah, I completely agree. It's just not a good architecture to begin with.
Thank you for the talk. From your experience, which is the biggest Celery pain point from your experience? Something that grinds your gears.
That's a great question, and I will say it is workflows. Having complex workflows with Celery, it was the seed that started all this movement from us to move away from having Celery handling everything, like workflows and chains and etc., and having something more Django-focused approach. So complex workflows with one task depending on the other. When task number 3 fails, what happens in task number 4, 5, 6? It's something quite complex to understand, at least in previous versions of Celery that we're working with.
Moving away from charts and groups where you control the status in the database. That's what you're
Exactly. Moving away from anything like complex workflows on Celery, using Celery just like a message queue, and that's it. But controlling the state on database was our goal.
Thank you, Ricardo. Thank you, everyone.
Thank you.